is somewhat different. So, what is the average in physics? Average must be calculated in physics for whole journey or whole journey of motion. Means from initial point to final point, not in between or the segments of journey, but as a whole. Average means as a whole, complete journey. That's why you have to take initial and final value for average. So if I say you, what is the average velocity, that you can say that total displacement between that point means S final minus S initial, or difference or change in displacement between that point. As I have already discussed in the previous lecture, how this difference gives the total displacement between 2 points. So it is nothing but the total displacement between 2 points, and it is nothing but the total time taken between 2 places in the journey. Have you got my point? So it means the total displacement divided by total time gives the idea of average velocity. It is not the actual velocity. Have you got my point? Actual velocity cannot be defined by taking total displacement or total time, because actual velocity is the velocity at every point of instant, every place, each point in the whole journey. Have you got my point? So at each point in the journey, each place in the journey can have different velocities. But you know, average gives the idea of central tendency or mid value, as we know in mathematics. So this gives the idea of mid value only, not the actual value. Have you got my point? So average velocity is total displacement by total time. Now let us give you an example that in the previous lecture I have given you this kind of problem already. So there, if you have to move from A to B along this path, and you have to take 1 second for this path and 1 second for this and 1 second for this, and you already know the length of this segment is 1 meter, and this segment is 1, and this segment is 1. So what is the displacement in this case? You already know the displacement given by a single straight line between initial to final point. That is, total displacement must be the line drawn by A to B, that is here. A dotted line gives the idea of magnitude of total displacement. Have you got my point? So you can find out by the geometry, this value gives √5. Yes or not? Can you find it out? This is 1 meter, this is 1 meter, this is 1 meter. You can construct a line, parallel line, and join it. Again, you can construct a parallel line and join it. You got a rectangle, and this is diagonal of that rectangle. You can find it out. So this is the total displacement. And in covering these total displacement, what is the time the object take? This is simply 3 seconds. 1 second, 1 second, 1 second. Total time is 3 seconds left by covering √5 meter displacement. So you can say average velocity is nothing but the total displacement divided by total time. So it becomes root 5 by 3 meter per second. Meter by second means meter per second. So I am giving you some problem. You can solve it by yourself. Find average velocity in all the previous cases if time taken in whole journey is 10 seconds. I have given you in the previous lecture there are many problems, and in all the problems you have to take the time 10 seconds, and then you can find the average velocity in a similar manner. So do it yourself in your notebook. Now what is the meaning of instantaneous? I have given you some glimpse about it already, that the actual value of some physical quantity, say velocity or speed, something like that, or acceleration, at every point of instant, at every point in the journey, that is the actual value of the object during motion. That gives the idea of instantaneous value of that physical quantity. That is instantaneous velocity, instantaneous speed, instantaneous acceleration, etc. Have a good memory. But here this point has velocity v1, this point has velocity v2, this point has velocity v3, this point has v4, this point has v5, this point has v6, and so on. This is the actual velocity of the object during motion. It may changes from one point to another, or it may be constant during the motion. It depends on the particular situation, that your speed is same or not, your velocity is same or not, your acceleration is same or not. If your speed is constant during motion, that means its instantaneous speed is same at every point during motion. Have you got my point? But in another cases it may change. It depends on problem or situation. But we have already told you that in a straight line motion, direction is fixed, so we don't have to bother about direction. We only take the value. So if you choose the single straight line, the instantaneous is equal to average if rate is fixed. Have you got my point? But in the curved line, or in the path of various segments of a straight line, instantaneous and average cannot be equal. So instantaneous means that the actual physical quantity at particular point during the motion. But in this class we don't bother about the how to find instantaneous value. We must deal this kind of problem in 11th class, because there is some mathematical tools you don't need to study here. It must demand the idea of differentiation. So I am not dealing the differentiation here now. So we only study in this class for simpler cases, for single straight line or straight line motion. So in this class we have to deal the simpler cases, that is linear motion or a straight line motion. In a straight line, direction is fixed, so you can say the magnitude of velocity is nothing but a speed. A speed gives the value. So in a straight line, if direction is fixed, then the value of velocity must be speed. Or I have already told you in the previous class that that in a single straight line, distance is equal to displacement. Have you got my point? In the same way, in a single straight line, value of this velocity is equal to speed. Have you got my point? This is the case. You can understand. Now, I have already told you average means the division of total to total, and speed is nothing but the rate, as velocity is the rate. And rate with respect to what? With respect to time. And it is a speed. So whose rate? Means rate of distance. Have you got my point? So average speed means total distance by total time. Or a speed is defined as the change in distance, the rate of change in distance with respect to time, as velocity is defined as the rate of change in velocity with respect to time. Only difference is there is in velocity there is displacement, and in speed there is distance, because speed is scalar quantity whereas velocity is vector. And average means total by total. That's why average speed counts only the final and initial value. It does not bother about what actually its value at particular instance is. It does not give the idea of actual value. Have you got my point? It's just a mid value, as you have already studied in statistics or data handling. So average speed is total distance by total time. How can you get the average speed in this case? So simply you have to count the total path length and you have to divide the total time taken. So here the total path length is 1 meter, 1 meter, 1 meter. This is total path length, and here the total time is 3 seconds, 3 seconds. So it becomes meter by second, and 3 by 3, 1 meter per second. I have already told you a scalar never be negative. It may be 0, it may be positive. Here it is only 1 meter per second. Have you got my point? It only cares about the path length, it means distance. Does not care about the displacement. I have already told you. Have you got my point? Now, I have already told you that in a single line, average speed must be equal to instantaneous speed. Or you can say, in a single line, average is equal to instantaneous, because direction is fixed. So average, if you evaluate the average, it also the value at particular instant, if the rate is fixed. Now I have a problem for you. This is a circular track, and a body wants to move from A to B along the circular track. So he moves from A and reaches to B, and he takes 20 seconds, and the radius of this circular track is 7 centimeters. Now the question is, what is the total displacement? What is the total distance or path length? What is the average velocity or the rate of change in displacement with respect to time? What is the average speed? Speed means rate of change of distance with respect to time. So what is the average? So how can you solve this problem? Can you do it? You can do it yourself, but I am giving you some hint here for this problem. The problem is, there is a circular track and the radius of this circular track is 7 centimeters. Now a body moves from this point and reach the diametrical opposite point at B. So the total displacement must be to the straight line joining the point A and B, and the direction is from A to B. So this is the smallest or straight line. So what is the value of this line? So total displacement is r plus r, radius plus radius, means diameter, which is 2 into 7 centimeter, which is 14 centimeter. This is the total displacement. Now you can find average velocity. Average velocity means total displacement by total time. Have you got my point? So here total displacement I have calculated 14 centimeter, and total time is total time taken from A to B is given as 20 seconds in the question. So it becomes you can solve it by yourself. 10 7 means 0.7 centimeter per second. You can change it in SI unit also. Now, what is the total distance covered in this situation? So here it covered the half of the circumference. Have you got my point? So circumference is given by the formula of 2 pi r, and half of it means 1 by 2. So 2 cancel, this is pi r, and pi is 22 by 7 and r is 7 centimeter, which is given. So 7 cancel out, it gives 22 centimeter. This is the path length, or it is total distance covered in the journey. So you can calculate easily the average speed, which is nothing but total distance by total time, which is 22 centimeter by 20 centimeter, which is 1.1 centimeter per second. Have you got my point? So this is our calculation or process of calculation. You can find out your answer. Now I am going to the next term, which is also important in kinematics, which is called acceleration. So as I have already told you that the rate of change of displacement with respect to time is velocity. But if I say to you, what will be the rate of change of velocity with respect to time? So I am saying the rate is very important in physics. Everywhere you confront about the rate in physics. So here is another rate. Acceleration is also the rate. We have already dealt about some other rate in the previous lecture. Velocity is also the rate. Speed is also the rate. But here another rate, acceleration. So acceleration is nothing but the rate of change of velocity with respect to time. Have you got my point? So it is a rate with respect to time whose rate it is? Change in velocity. Have you got my point? So the rate of change in velocity with respect to time is given a special term, a special name by physicists, which is known as acceleration. Have you got my point? So you can in the similar fashion as you already you have taken in the previous lecture, you can, by the definition, you can find out the mathematical expression of this acceleration, which is nothing but v final minus b initial by t2 minus t1, means the total the change in velocity, delta v, change in velocity by changing time or total time during the motion from one point to another point. So for simplicity, I replace this symbol in an easier way so that it take less time and it is easier to handle this. Have you got my point? So I replace bf vector, final vector, which is b, final velocity, which we replace as v, and the initial velocity we replace as u. Have you got my point? And now total time t2 minus t1 from one point to another is replaced by the single term t. Have you got my point? So now the mathematical expression of acceleration by its definition becomes a is equal to v minus u by t. Means acceleration is nothing but the rate with respect to time of change in velocity. Means difference in velocity from one point to another. Have you got my point? So I have got an important expression a is equal to v minus u by t. This expression is very, very important. Have you got my point? So I am giving you a problem so that you can understand the concept, what the term it is. So I am giving you a situation that here you start your bike at rest. So at this point the speed of or velocity of your bike is 0 meter per second, and you headed your bike towards east or towards a fixed direction along a straight line at some rate, or accelerate your bike at some rate. I don't know and you don't know what is the value of your acceleration, but after reaching some point here, you see in your bike that the speedometer gives the value of 20 meters per second here, and you count the time, and your watch say I have taken 5 seconds from the initial point, from the start. Have you got my point? So how can you find the rate at which you move? This is simply by the definition. You know that the acceleration is nothing but, rate is nothing but the change in velocity with respect to time, that is v minus u by t. So here final velocity you got is 20 meter per second and initial velocity you got is 0 meter per second. So change in velocity is nothing but 20 minus 0 meter per second, and you got total time t2 minus t1, which is nothing but 5 seconds. So you divide it and you got the rate, which is 20 by 5 meter per second by second, which is nothing but meter per second square. So it gives the rate is, your rate is 4. At the rate of 4 you are moving, or you are increasing your speed from 0 to 20 meter per second. Have you got my point? And the unit of acceleration is nothing but meter per second. You have to remember it. Unit of acceleration is meter per second, and unit of velocity is meter per second, as unit of speed is meter per second, unit of average speed is meter per second, unit of average velocity is meter per second, unit of average acceleration is meter per second. Means any kind of a term which is related to the same term, means average, instantaneous, all have same unit. I have already told you in the previous class, in the previous lecture, about the unit of various physical quantities. So here I replace B final to B and B initial to U, and T2 minus T1 is to T. Have you got my point? Now you have understand how can you find the rate of the motion if the speed changes. Have you got my point? Now I give you different situation here. If somebody moves from A to B and its speed of the bike changes from 0 meter per second or at rest and to 20 meter per second at B, and it takes 5 seconds to reach at B. Now from B its speed is declared, or the bikers slow down his or her bike, and the velocity at C becomes 10 meter per second, and it takes 5 seconds from B to C. What is the rate in this case? Or what is the rate from A to B? What is the rate from B to C? Or what is the rate from A to C as a whole in a whole journey? Here you can solve it. Rate from A to B, you can see here the final velocity is 20 and the initial velocity is 0. So it is nothing but V minus U by T. So 20 minus 0 meter per second by 5 seconds. So it gives 4 meter per second squared. Have you got my point? So the rate of biker's motion is 4 meter per second from A to B. Now from B to C we do the process in a similar way. We got minus 2 meter per second because the final velocity is 10 and the initial velocity is 20 and the time taken is 5. So 10 minus 20 by 5, so you got minus 2 meter per second. I have already told you acceleration is a vector quantity, so it may be negative. And negative also give the some idea. Here you can see the velocity of biker is increases here, but the velocity is decreased in this situation. So negative sign indicates the slowing down the speed of some object, but the positive sign, here is the positive sign, gives the idea that the speed or velocity is increases. Have you got my point? If velocity increases means the acceleration or rate is positive. If velocity decreases means its rate is negative. And the negative rate is known as a special term which is called deceleration or retardation. Have you got my point? But for whole journey from A to C, we say that for whole journey this is an average. So you can find out the average of acceleration. That is nothing but the sum of data by number of data. So sum of data is here by number of data. So you can find out, you can take it will 4 and plus minus 2 means 4 minus 2 means 2, 2 by 2 means 1 meter per second. So for whole journey, you can say that average acceleration in this journey is 1 meter per second, but it is not correct because it does not give the actual answer, because here for A to B its rate is 4 meter per second and here B to C its rate is minus 2 meter per second. That gives the idea of actual case. Have you got my point? How you find average and the actual value of particular situation. So negative signifies the direction. Acceleration, if the direction of acceleration is towards let's say towards east, then the acceleration of direction of retardation must be towards west. It also means that if speed or velocity increases means it has acceleration, means biker accelerate the bike. Or if rate is negative, it means biker decelerate or retarded the bike or slow down the bike, or its velocity it becomes decreases. Have you got my point? This is the meaning of negative sign here. Now the last term here I am to discuss here is rate of change of speed. You have already know about the rate, so it is not a special thing. You have already known about it, that rate of change in velocity is called a special term as acceleration, but here rate of change in speed has no special term, because it does not needed in physics in various cases. Most of the cases it only comes for few cases, so it does not have a special name. You simply say it rate of change in speed. Have you got my point? But if you change the speed in velocity, it becomes acceleration. So rate of change of speed, as a speed is scalar, so its rate of change of in a speed is also scalar quantity. But in previous case, a velocity is vector quantity, so its rate is vector, so acceleration is vector. So it's a scalar quantity, rate is and changes speed. So its formula may be the total change in speed during that motion and total time. So v2 minus v1 by t. But the caution here is v2 or v1 is not the velocity here. It's only speed. First of all, I remind you about what is rate in physics. As in your daily life, rate means that in 1 kg how much quantity you get. Or you want to buy some pen and the shopkeeper say 10 rupees per packet. Here you also already knew about the rate, but in a different way. Here the rate is with respect to packet or number of packets. So in the value of 1 packet is here 10 rupees. Have you got my point? In this way, in physics, the rate is defined with respect to time. So you have to deal with how a physical quantity changes in 1 second or 1 minute, whatever it is. If you take a SI unit, it is 1 second. And you know that in mathematics, if you want to take the value for 1, it means we divide the quantity, as you already studied in unitary method. So this is nothing but unitary method. If you want to find the rate, you have to divide. You have to proceed as unitary method. So generally in physics, rate is defined with respect to time. So if I give you a definition about velocity, it is defined as the change in velocity with respect to time, the rate of change in velocity with respect to time. And for speed, rate of change in distance with respect to time. For acceleration, rate of change in velocity with respect to time. Have you got my point? And what is the difference between velocity and speed? Speed is scalar quantity, velocity is vector quantity. And all the differences which possess vector and scalar are also true for these cases also. These cases also. Have you got my point? And you have already got the mathematical expression by the definition of it, that the mathematical expression of velocity is nothing but the change in velocity, change in displacement means as final minus as initial by time, total time taken, or time interval t2 minus t1. Have you got my point? Similarly, we have defined the mathematical expression of speed and mathematical expression of velocity. So the most important expression of this lecture is A is equal to V minus U by T, because in most of the cases in your class it is used. You have to remember it. Now I have already told you about average and instantaneous. Instantaneous gives the actual value at every point of instant during the motion, during the journey. But average is the just a value which gives the idea of mid value. As you already studied in statistics as mean. Mean also means average. Have you got my point? But in physics it is given differently, because every physical term has some special meaning, some special definition, and you have to deal according to that definition. Have you got my point? I have also given you some examples how to solve it, how to find out average velocity, average displacement, average speed, average acceleration, or total displacement, total distance in the different cases. So now you have to go to your book and solve more and more problems, so that you have to get a skill in the numerical solving ability. Have you got my point? More the problems you tackle, more the concept you get, and more understanding you empower. So in the next lecture I must deal about the various concepts in motion, and also deal about how these terms can be used to understand other phenomena in motion. Thank you.